All right, lesson number 2. Now, February. I started recording these in February, right? In February, there was actually a lot of UV sunlight. So the sky, um, when the sky is super clear, you get a lot of uh, ultraviolet light falling in. And this year we had a huge bathing of ultraviolet. Now, the sky could only really be one of two things. It could be clear or it could be cloudy. It could also be partially cloudy. And now, so there's and I can see that right there, there's like a little bit of a cloud. So, yeah, clouds do exist right now. And there's different types of clouds. There's cumulus and strato and all those things. Like some of those, cirrus, I believe, would be in the very highest part of the atmosphere, and they would just look like shreds. They would look like thin lines over there. Or whenever the nimbus cloud forms, there's something called the LCL, the least condensation level, and you can see like a proper line at the bottom of the cloud, and then it goes up. But there's a line that you can see right on top of the surface, which is like, that's where the cloud forms. It's called the least condensation layer. What you see right now is a drop in the visibility. So what's happening here is it's not clear, right? There's like smoky texture all over and in the depth as well. And if it is as smoky out there, it's probably as smoky where you're standing. You just don't see it as much when it's closer to you. If I had an infrared light that I could fire at the top of that mountain or any of those buildings over there, and if it had a mirror that could bounce that same light back to the source, and if I could get the timing for the infrared beam to cross from that place to here, right? If I could get the timing down to the nanosecond on a clear day, the first measurement on a clear day, I would know how long it takes for that line to work. And if I compared that same timing on a day like this, right, I would see that the time the infrared light takes to go from here to the top of that mountaintop and bounce back is higher, or it takes more time than on a clear day. Why is that? Because there's more disturbance between here and there. There's so it's not fog, it's not smoke. One thing, all right, I don't know if this will be clear enough, but right next to those 3 coconut trees, there's like 2 or 3 layers of hills that can sort of be seen, and there's a little tint of yellowish, or like the color over there changes a little bit to I don't know if it's clear enough. It's very hard to see, but it's not completely white, it's not completely gray. There's a little bit of sunlight refracting within those layers, and that's probably sulfuric. So one of the major contributions to this sort of thing is sulfuric, but it's not just sulfuric. There's also carbon monoxide, which is quite common in fires and stuff. And say me and a friend of mine, we both noticed the first time that this happened in 2021 or 2023 or something, when there were these huge agricultural fires in the south of India, and the smoke just flew in, or it got pushed over to Sri Lanka. And I was traveling on the Peradeniya Road to work, and the entire road was just covered in smoke, right? But here's the weird part: for there to be smoke, as the saying goes, right? Where there is smoke, there is fire. So we looked for a source. Like, where is all this fire coming from? Where is all this smoke coming from? There has to be a single fire or several fires spread across everywhere. But no, it was just one uniform sheet or layer, or you can't call it a layer because layers go vertically, but this was horizontally. And if you take the vertical profile of it, it was just equal everywhere. It wasn't thicker at any point or less dense at a different point. Now, normally when the fog rises, right, at this time of day, when the sun hits the earth heats up, and the fog would rise as, like, thick on the lower side, and then eventually it would just rise up, and then become clouds on top with nothing left on the bottom. But here, that's not what's happening. It's the vertical profile here it's obviously filled in smoke or disturbance, as I would call it. So you got the SOx and the NOx, which is sulfur dioxides, and then nitrous oxides, and then a little bit of carbon monoxide. Carbon dioxide is normal, right? But carbon monoxide is proof of smoke or fire or partial combustion, you know? And so we don't have NOx here, I don't believe, because NOx would look brown. Even the color of the sky at this hour, this is like, this is mid-morning, and it's not supposed to look pinkish or greenish or any kind of thing. The spectrum of the colors that you see in the sky right now, it's unnatural. It's unnatural. Especially right over there, there's like a little bit of refraction. It's like greenish or something. You can see the color of the sky, sort of, but there's also this other stuff. And this is so normally SOx and NOx are produced in industry heavy places where, for example, if you have refineries which burn a lot of crude oil and separate them into propane and LP gas and all these stuff, you're gonna have a lot of smoke in the surrounding atmosphere, and everything's gonna look brown or different colors, red, pink, even. Pollution can be really beautiful, yeah, but it's significant, or it's a telltale sign of something that shouldn't be there being there. So the entire horizontal profile over here from one place to the other place, if you take that, right, it's all equally distributed. There's a lot of smoke going over here. There's a lot of disturbance from here to there. Like, the depth of this range is pretty thick as well. And we're gonna talk a lot about what happened to the cattle in Vaunia and Mulativ and Anuradhapura during that first wave of pollution. So yeah, what's funny about this is we live in a third world developing Asian country. We're not third world anymore, but we got the pollution levels of an industrial colony, but the economy of the economy the economy of still agricultural country, which is fine. I like agricultural countries. I like we don't need to be an industrial civilization necessarily. Well, it depends on what industry we're talking about and all that, but when I mean industry, I mean, like, fossil fuels. And but at this level of pollution, if we had the resources and the money that come with it, yeah, sure, fine. If it's a byproduct of something important, we could kind of say, like, hey, you gotta break a few eggs to make a scramble. You gotta break a few eggs to make an omelet. But I see the eggshells, right, and the corn husks or whatever. There's nothing you get out of it. This is just a byproduct of something else. We don't know where it's coming from. It's probably coming from somewhere else. And this is probably the fifth consecutive year that we're seeing this.